Hello everyone, welcome to Stats with Supreetha. In our previous episodes, we learned about mean, median, mode, range, quartiles, and measures of dispersion. Today we are going to learn two very important concepts in statistics, variance and standard deviation. By the end of this video, you will understand them in the simplest way possible. So, let us begin. The big question: how spread out are the values? Imagine two classes. Class A marks 48, 49, 50, 51, 52. Class B marks 10, 30, 50, 70, 90. Both classes have same mean, that is 50. But are they really similar? No. In class A, the marks are very close to 50. In class B, the marks are spread far away from 50. So the mean alone cannot tell us the full story. So we need a measure that tells us how far the values are from the mean. That is where variance and standard deviation helps us. So what is standard deviation? Standard deviation tells us on an average how far the values are from the mean. Think of it like this. Imagine the mean is center of a playground. If children are standing close to the center, the standard deviation is small. If children are scattered all around the playground, the standard deviation is large. So, standard deviation is simply the square root of variance. Because of the square root, the answer comes back to the original unit. For example, if heights are measured in centimeters, then standard deviation is also measured in centimeter. That is why standard deviation is easy to understand and widely used. Now, what is variance? So, variance is the average of squared deviation from the mean. Sounds complicated? Let us simplify. Step 1, find the mean. Step 2, see how far each value is from the mean. This difference is called deviations. Step 3, square each deviations. Step 4 is find the average. The average is called variance. So, if variance is small, the data is closely packed. If variance is large, data is widely spread. So, why do we square the deviations? This is one of the most important questions in statistics. Suppose the mean is 50. Consider these values 40 and 60. Their deviations are 40 minus 50 is minus 10, 60 minus 50 is plus 10. Now, if we add them, that is minus 10 plus 10 equal to 0. The deviations cancels each other. It looks like there is no spread at all. But clearly, the values are far from the mean. So, averaging raw deviations doesn't work. So, the solution is square each deviation. That is minus 10 square equal to 100. 10 square equal to 100. Now, all values becomes positive. Nothing cancels out. And we get a true measure of spread. That is why variance and standard deviation use square deviations. Okay. Now, population variance and standard deviation. Now, let us learn the formula. When we have data from the entire population, we use n in the denominator. So, the population variance is sigma square equal to 1 by n summation I equal to 1 to n xi minus mu whole square, where sigma square is population variance, xi is each value, mu is the mean, capital N is the number of observation. So population standard deviation is sigma equal to square root of 1 by n summation I equal to 1 to n xi minus mu whole square. Simply take the square root of variance. Now sample variance and standard deviation. Sometimes we do not have the entire population. we only have a sample. In that case, we use n minus 1 instead of n. Okay. This adjustment is called Bessel's correction. Okay. Now see, the sample variance is s square equal to 1 by n minus 1 summation I equal to 1 to n, that is sample size n, xi minus x bar whole square. So the sample standard deviation equal to s equal to square root of 1 by n minus 1 summation I equal to 1 to n xi minus x bar whole square. Now remember the easy trick, the for population we divide by capital N, for sample divide by n minus 1. Okay. Now let us calculate variance and standard deviation. Uh, okay, so the data set is 60, 56, 61, 68, 51, 53, 69, 54. Find the mean. So mean is, we already calculated, it is 59. Now calculate the deviation, that is xi minus x bar. 60 minus 51, 60 minus 59, that is 1. 56 minus 59, that is minus 3. Similarly, do it for all the data set. So we get the deviation 1 minus 3, 2, 9, minus 8, minus 6, 10, minus 5. Now square the deviations. That is 1 square 1, minus 3 square 9, 2 square 4, 9 square 81. Similarly, all the data set we add up, add all the square deviation, we get 320. This, so let us find variance. Variance is summation xi minus x bar divided by n. So summation xi minus x bar whole square, we got 320. Total number n is 8. So 320 divided by 8 is equal to 40. So variance is 40. Now standard deviation is square root of variance, square root of 40, which is approximately equal to 6.32. This means the values are typically about 6.32 units away from the mean value of 59. That's the real meaning of standard deviation. So let us quickly recall. So variance, the average square distance from the mean, measures spread but in squared units. Standard deviation, the square root of variance, returns to the original data units, practical and interpretable. Okay. Reading the value, smaller standard deviation or variance, consistent data, larger standard deviation or variance is more spread out and more spread data or variability. Okay, if you found this video helpful, don't forget to like, share and subscribe to Stats with Supreetha. Thank you so much.